In this video, we're going to talk about completing the square to help us solve a quadratic equation. Okay, maybe I have the equation x squared minus 8x plus 2 equals 0. Now, if I was given no further instructions other than solve this for x, then we would go through the checklist that we've learned already, and we would start by saying, can I factor this polynomial? We could determine pretty quickly that there are no two factors of 2 that add to be -8, which means this isn't going to factor. Also, the only other approach that we know so far is to use square roots to help us solve. And when I have this 8x term right here, I don't just have x squareds in numbers. I know square roots aren't gonna help us either. So completing the square is one of those methods that's not terribly fun for students. They don't particularly enjoy doing it. And in all fairness, if I left this video lecture out of the list and just talked about the other three methods, we could still solve any quadratic equation in the book. But this is an important method to understand for other reasons when we get to college algebra. And so we're going to at least show you how it works here this semester. The first step when we're completing the square is different from when we're factoring, where we like to have the 0 on one side. What we're going to do instead is we're going to leave the x squared term and the x term where it is, and we're going to add or subtract the constant to the other side. Then what I'm going to do, this is where I really wanted the purple, is I know I'm allowed to do anything I want to an equation as long as I do the same thing to both sides. Okay, that goes for addition and subtraction, like we did up here. That goes for multiplying and dividing, as we're used to doing with our other equations. And usually we do that to move terms from one side of the equals to the other. Okay, here, what we're going to do instead is we're going to pick a number to add here with the x squared minus 8x. So that when I have this new trinomial, it's not only going to factor, but it's going to factor nicely into a perfect square. Now, if you are curious about why this is the way it is, I'm not going to go into the whys, I'm just going to go into the hows. Please let me know, or look in your book, I'm sure it explains it. But most students are like, just tell me how to do it, Miss Jackson. So that's what we're going to do. You take this number out here, the coefficient of the x, which is -8, and you divide it by 2. Okay, no matter what this number is here, you always divide by 2. And then you're going to square it. So half of -8 is -4. And if I take -4 times -4, I get +16. That's the number I'm going to add here on the left. Now I can't just randomly add a number on one side of an equation without doing the same thing to the other side. Otherwise, I've broken the rules. So I'm going to add 16 to the other side as well. Okay. On the right, we do the arithmetic and put our like terms together. On the left, now we're going to factor what's here. The two numbers that multiply to be +16 and add to be -8 are -4 and -4. Now, in the last chapter, I liked to write them side by side, x minus 4 and x minus 4. Okay, but here I'm going to write it this way, x minus 4 quantity squared. Now, if we look at this expression here, now this should start to look familiar to us. In the video that you just watched, talked about using square roots to help us solve for x. Okay, now I have created a situation where I started with something that didn't factor at all. And I not only made one side factor, but I made it factor as a perfect square. Which means I can get rid of the square by taking the square root. And if I put the square root into the problem myself, I also have to put plus or minus. On the left, then, all that remains is x minus 4. If we look at the square root of 14, there's nothing more we can do with it. So we have plus or minus square root of 14. If I want to get the x all by itself, finish finding the solution, we're going to add 4 to both sides. So the two solutions for this equation are 4 plus square root of 14 and 4 minus square root of 14. And so the process of completing the square takes something that maybe didn't factor at all, or if it did, it didn't factor nicely. And we not only make it factor, but we make it factor as a perfect square. That allows us to use our square root property, our square root process that we learned earlier on, to go ahead and solve for x from there. If we start with x squared plus 2x minus 5 equals 0, and if the instructions just say solve for x, like they will on your test, I'm not going to say solve for x by completing the square. Okay, so we look and say, I hope I can factor this, and it turns out that I can't. So I push buttons on my stand. So the first thing I'm going to do if I'm completing the square is I'm going to add 5 to both sides. So I have the x squared and the x term by itself, the constant on the right where it's out of my way. Then, I want a different color. Okay. From there, I'm going to figure out a number to add to both sides so that when I factor the left side, it factors as a perfect square. We start with this coefficient here, which is a 2. Always divide it by 2, regardless of what it is. And then we square it. Half of 2 is 1. 1 squared is 1. So 1 is that magic number that I'm going to add to both sides. On the right, we can add the 5 and 1 together and get 6. On the left side, the two numbers that multiply to be 1 and add to get 2 are positive 1 and positive 1. Now that I have something with x squared equal to 6, we can take the square root of both sides. Don't forget to put your plus or minus in there. X plus 1 is plus or minus square root of 6. And then when we subtract 1 from both sides, x is negative 1 plus or minus the square root of 6. Here's our two solutions. Go ahead and pause the video and try this one on the right, and then we're gonna add some other steps to it. Okay. So first thing I do is I move that 10 to the right by subtracting it from both sides. Half of negative 6 is negative 3. If I square it, I get positive 9. Following on down at the end, I'll let you read through these, pause if you need to. You should get 3 plus or minus I for your solutions. Go ahead and try this one. It's got a little twist to it. Pause the video, give it a shot, and then come back to see if you're okay. When you add 6 to both sides is the first step. And notice when you go to add this coefficient or this constant, it's not the same as it was in the other 3 examples. If I want to take half of 3, I don't get a whole number. But squaring a fraction is no big deal. We square the top, square the bottom. Okay. Now when we go to factor, this is where some of you will get lost. When we're factoring, when we're completing the square, that opens some doors we haven't used before. And that's factoring over the rational numbers instead of just the integers. When you go to factor this expression, every time, this is what goes in next to your x. Positive 3 over 2, positive 2 over 2, negative 6 over 2, negative 8 over 2. So it's always going to be x plus half of this number, keeping the sign. From here we take our square roots, plus or minus. Okay, again, don't freak out with the fractions because worst case scenario, we're adding fourths to both sides. And when we take square roots, notice what happens. We're back to halves. So we're dealing with halves and fourths, which are not scary fractions in the whole grand scheme of things. And here we go. Here's our two solutions. I'm going to have to wrap this video up because I've got two more examples, and I think I'm going to run out of time. Actually, maybe I'll try to squish them in there. You guys will just have to pause more. If I have a coefficient other than a 1 in front of my x squared term, that creates problems with more steps. I am going to make another video because I want to do several of these. So stay tuned for part 2.